Alright, so I specifically again gave this study guide to you so you wouldn't have so much to write. We're going to talk about parallel lines and distances. As soon as I get my pens together. You might need a straight edge. So some important things, and these should be on your flashcards. If they're not, make a flashcard for them. For this box right here. Let's talk about it. The distance between a point and a line. The distance from a line to a point not on the line is the length of the segment perpendicular to the line from the point. Here's the point. Ha ha ha. So here's a line. And then here's a point not on the line. So it's a little different than the theorem that you had yesterday. What they're saying is, what's the distance from this point to this line? Is the distance represented by this length from here to here? Or by this length from here to here? Or by this length from here to here? Or this length from here to here? Or this length from here to here? I mean, couldn't I do an infinite number of lines from this point to this line? Couldn't I draw an infinite number of lines? So somewhere along the line, somebody had to come up with a rule to say, well, which of those lines represents the distance from the point to the line? 100% of the time, it's going to be the line that's perpendicular from this point to this line. So all you need is a straight edge for this particular exercise. So it doesn't have to be a ruler, it can be your student ID card, you know, whatever you have handy, but it has to be a straight edge. It can be a note card, something that has a right angle to it. So I'm going to use my rulers way too big. Well, maybe I'll just move this down. It's in the way of my projector. Darn it. See if I can find something shorter like a card. I don't want to use my cell phone. Same line. Wait, I have a Starbucks card. Alright, so here we go. Alright, so I'm going to use my Starbucks card because it has a right angle. It's right enough for government work, isn't it? And all I'm going to do is run this card along the line so that it's straight along this line until I run up against that point. There it is. So if I draw a dotted line from here to here, this line right here represents the distance from the point to the line. It must be perpendicular. So all that theorem says. So then this one right here says the distance between parallel lines, and so here's an example of, well, obviously that's not an example of parallel lines. Let's go way down here. See number 5? Those appear parallel. So all this one here is saying is that the distance between two parallel lines is the distance between one of the lines and any point on the other line. So if I were trying to find the distance between these two parallel lines, I would have to find a point on one of the lines and then run my ruler or my straight edge along the other line. So I've lined this up here, and I'd have to run it along there until I got a perpendicular distance. So this right here would represent the distance between those parallel lines, and I could have done that with any point on the line. So if I chose this point right here, do the same thing, run my ruler across there until I have another perpendicular distance. So this would be distance sub 1, this would be distance sub 2, and hopefully if they're parallel lines they should be the same. So I actually took out the questions in your homework that said use a ruler to determine the distance, because you'd actually have to measure, and I chose not to do that. But anyway, that's what you would have to do if you were determining if you had parallel lines. And that's all that this one is saying up here. So let's look at how do we find, because you're going to have to find heights. Heights are always the distance from a vertex to the opposite side. And for some figures that tends to be difficult for some of you. Others of you who are spatially gifted and just see it have no issues with this particular exercise, but there's some of you that this is going to be a struggle for you. and others you're not going to understand why that they have a struggle. So look at this example right here. Now they've already shown you the distance. Sometimes the distance is outside a figure, bless you, sometimes it's inside a figure. So if I'm finding the distance from E to AF, so here's AF right here. So if I'm finding this distance from E, I don't know why that doesn't want to show up, to AF, if I tried to draw from the point to the line as it is that going to be perpendicular right there? Right there, right there. There is no point from here to here that's perpendicular. So sometimes you have to extend out this line right here until you get enough of the line that you can make it perpendicular. So here I am running my ruler along the edge of AF and along the extension of AF until I hit, oh, this point C. And so now I was able to draw a perpendicular distance from E to AF. Now AF is extended to AC. So you might have to do that. So look below, look at questions 1 through 4. And that's what we're going to end up having to do. You might have to turn your paper to do this. Some of you don't need to turn your paper. But we're going to draw a distance from K to HJ. So here's K, and here's my HJ. For this one, again, I just want to run, and I think I'm going to use my Starbucks card. So I'm going to run my card along here. I want to make sure that it's lining up along here, the bottom. I'm going to run my card along here until my card lines up with the bottom and with my point there. And then some of these cards have rounded edges like this one, right? So at the very bottom, just finish it yourself and put a right angle there. And then this is my distance. That would be the height of your triangle. But look at number 2. If I were to try to draw from A to BC, as I run my card along BC, I run out of BC before I get to my point, don't I? So I need to extend BC in order to get my distance. So I'm going to extend BC, and now when I run my card along there, now my distance is outside the figure. Right there. So there is my distance from A to BC. You don't have to create another point like they did in the example. You don't have to create this point and say, oh, this is F. Not necessary. You could if it makes you feel better. So you do 3 and 4 on your own. Make sure you're lining at the bottom of your straight edge with the line that you're finding the distance to. So do you agree? For some of you, you're experiencing frustration at this point, aren't you? It's normal. It happens. Don't be upset. Your brain is wired differently. Yes. How did you do it?
I extended that line down so that
Can I see your paper? Bring it up here. So Jade, and I'm just going to show you because this is a visual thing, because I too wanted to do that as well, because that's the way my brain works. However, watch what happens when I run a perpendicular line against that. This is perpendicular to this line. Do you see how your line is not? So be careful with that. So run this along here this way. And this is a very common thing to do because it looks like it should be outside, right? Because you want to be going straight down this way. So oftentimes I'll turn my paper so that this is east-west, and then it kind of forces you. It's still a visual thing. But if you get used to or get in the habit of running this along here, then you'll say, oh, okay, I didn't mean to do that. There was that perpendicular line. Does that make sense? Yeah. I'm glad you asked that question. Good. So there should only be one distance or one place that you put that distance. Does that make sense? Okay. All right, so I'm not going to do anything more down here at the bottom, so you can cross out that part. We're not doing constructions today. So flip it over. A couple examples to do here. So again, I want you to draw the segment that represents the distance indicated. So from P to RS, so try again. So if I were you, like on this one, I would turn my paper this way. If you're a visual person that has some issues with that, physically turn your paper. And when you're doing this out of your textbook, you can put your graph paper over the textbook and copy the picture that way. Don't draw in your textbook. So shouldn't that be my distance? Some of you didn't need to turn it, but there's the distance right there. To me, it's harder to do it if I don't turn it. And then for number 2, B to AD. So I'm going to turn my paper this way. And run my straight edge along here. So that one's that one was inside, the other one was outside. So for some of you, you're like, I don't get why people are having issues with this. Again, this is that spatial thing. Stop it. You can't help you're gifted. The rest of us are like, huh? Okay, I'm uncomfortable with that. That's fine. All right, so then look at 3 and 4. This is the harder questions out of your homework, and you have about, I don't know, 4 to 6 of these to do. So let's talk about them. They require a little bit of work, and they require a blast from the past known as the distance formula. So number 3 says graph each equation and plot the given ordered pair. Then construct a perpendicular segment and find the distance from the point to the line. First of all, your line has to be in slope-intercept form. It has to be in y equals mx plus b, right? Where m represents your slope and b represents your y-intercept. This equation is solved for y, isn't it? Where does it cross the y-axis? Where does this equation here cross the y-axis? 2. So you're going to plot a point at 2 on the y-axis, because your starting point should always be the y-axis. And then what's the slope? 1. So I'm going to have to write the slope as 1 over 1, or switch both directions, bless you, negative 1 over 1. You're either going to go in 2 positive directions or 2 negative directions. So remember, you have to rise up or down before you can run right or left. So I'm going to go up 1 to the right 1. Up 1 to the right, up one to the right, and so forth. I'm just going to fill in this whole graph as far as I can go, and then connect. So here's the equation, or the graph of the equation of that line. Then plot your point. So the point that they gave you is 2, negative 2. So to the right 2, down 2. Now, you could just take your straight edge and do what we did before, but you're not allowed to do that here. What do we know from the last section about perpendicular lines? Or whatever section we did. Was it the last time? It's been so long. What do you know about perpendicular slopes? What are they to each other? They're opposite signs and reciprocals. So what is the perpendicular slope to this line? If the line's 1, what's the perpendicular slope? Negative 1. The reciprocal of 1 is 1, so it's one of the weird ones. So we're going to do negative 1. If I slope, shouldn't it really be? Or I can change both directions, positive 1 over negative 1. I just changed both signs. So in other words, for a negative slope, I have to go in one positive direction and one negative direction. So I'm going to start out, I want to go towards this line. So if I go down 1 but to the right 1, is that going to get me to that line? Yes or no? No. So I want to go up 1 to the left 1. So I'm going to go up 1 to the left 1, plot a point, up 1 to the left, plot a point, up 1 to the left, plot a point. And now I've created that perpendicular distance without the use of a straight edge with a right angle. So this represents my distance right there. Now the other part of this question says, find the distance from the point to the line. We have to find the distance of this line segment. So this ordered pair that they gave us is 2, negative 2, isn't it? What's this ordered pair, which is the other endpoint? What's that ordered pair? Right here. Negative 1, positive 1. So we're going to use our distance formula. I'm going to let this be x sub 1, y sub 1. I'm going to let this be x sub 2, y sub 2. And then right here I'm going to do my distance formula. So I'm going to move this over a bit. Remember, your distance formula is something to this effect. The distance between your y's, or the difference between your y's squared, plus the difference between your x's squared. And all of that's underneath the square root. So it's your blueprint. Substitute in for the x's and the y's. So I'm going to sub in for y sub 2, negative 2, y sub 1, 1, x sub 2, 2, x sub 1, negative 1. So add your opposite. So I'm going to do plus a minus and plus a plus. So I end up with negative 2 plus a negative 1 is negative 3 squared plus 2 plus 3 squared. Now, having said that, well, we won't do that here. All right, so we've got 9 plus 9 is equal to what? Square root of 18. Can I simplify the square root of 18? Are there any perfect squares that I can pull out from 18? What? 9. So you can do one of two things. You can either say that this is 2 times 9 and recognize that the square root of 9 is 3, but some of you are going to need to go even further and say 3 times 3, and you're going to have to look at all of your primes. So if I have the square root of 18 and I change it to 3 times 3 times 2, can't I pair up my 2 3's and bring that out in front? So really my answer is 3 radical 2. There's your distance. So those require a little bit of work, don't they? I'm going to get you started on this one, but we're not going to finish it. So I just want to talk about this one and as far as how we start it. What's wrong with this one, or what's the difference in this one versus number 3? It's not solved for y. So how would you solve this for y? subtract x. Make sure your x comes first though. So if I subtract x, don't I have y equals a negative x plus 2? Which means that my y-intercept would be what? It's still 2 like before, so here's my 2. This time my slope is what? Yeah, so my slope here is negative 1 over 1, or change both signs, 1 over negative 1. So you have to go 1 positive, 1 negative. So if I go up 1, I have to go to the left 1. Up 1 to the left, up 1 to the left. Or down 1 to the right. Down 1 to the right, so forth. So there's the line. And then the point that they gave you is 3, 3. So this would be the point. What's the perpendicular slope to negative 1? Positive 1. So positive 1 means I'm going in 2 positives or 2 negative directions. So it's 1 over 1 or negative 1 over negative 1, right? So my perpendicular slope is equal to positive 1. So if I go up 1 but to the right 1, am I going to get to the direction of my line? No. So I want to go down 1 to the left 1, down 1 to the left 1. This is going to represent the distance from that point to the line. Take, and this part we're not going to do, you would take this point of 3, 3, and what's this point right here? 1, 1, 1. You would take the point 1, 1 and 3, 3 and run it through the distance formula and find your distance. Okay? Alright, so let's do the last part, which is down here. You have a section in your homework that's similar to this as well. So in the figure below, segment BH is perpendicular to segment AE. And haven't they given you that right here and right here? So they've given you that marker right here. And they said that CF is perpendicular to AE. So they've given you that marker here. And then BH is perpendicular to BC. So BH and BC, there's that marker here. And BC is perpendicular to CF, BC and CF. There's that marker there. And finally, one more, GD is perpendicular to CE. We have a whole bunch of perpendicular segments. So here's what you got to do. Name the segment whose length represents the distance between the following points and lines. This is hard for, again, those of us who are spatially handicapped, so to speak, because there's a whole bunch of things going on here at once. So here's what I want you to do. Here's this point B to AE. So find B, and where is AE? Here. I want you to keep your finger on that point, and I want you to take your straight edge, and I want you to line the straight edge up with that line AE. So here I'm lining it up with the line AE. Run, don't move your finger, because that's the point we're looking for. Run your card towards your finger until you hit it. What line segment is representing that distance? BH. So that one wasn't so bad, right? So let's go G to CE. So again, find G to CE. Well, if I were you, what would I do? I would turn my page. Very good. So I'm going to turn it over this way. And again, I'm going to put my finger on G, and I'm going to line my card up with CE. So I keep talking to myself. It's all right. Mathematicians are crazy. All right, so here we go. So as I line it up with the bottom and I hit my finger, what line am I touching? GD. All right, you try 7 and 8. What'd you get for the last ones? BC and CF? Does anybody need me to show you that? Okay. All right, so that's it for today. Your homework is page 158, 14 through 34 all.